Hi and welcome to this new video tutorial. We're going to see some really basic shape detection with OpenCV. Let's take, for example, this image called shapes. We have a rectangle, a circle, a triangle, a pentagon, ellipse, and a rectangle again. Actually, this is the first one, the green one, it's a square, and this one is a rectangle. Let's see how to do that. We import CV2, we import numpy as MP, we load the image, img it's equals to cv2.imread, and then shapes.jpg. We want to read this image in grayscale format because we don't need to use any color to detect the shape. So cv2.imread grayscale. Let's show the image. cv2.im show shapes and emg. Wait key event. So cv2.wait key 0, and finally cv2.destroy all windows. Let's run the code to see if everything is correct, and it is. Here we have all the shapes. One thing that we can notice at first is that they have all different colors, and I mean different gradient. This one it's really clear, this one is darker, and this one it's really dark, and so on. We don't need that. To have the shapes, we need only black and white. So now we need threshold. Threshold will be underscore threshold. It's equals to cv2.threshold of the image. We give a value of, let's say, 200 and 255, and cv2.thresh binary. Let's see what we get with this threshold. Actually, I'm not showing it. So let's show the threshold. cv2.im show threshold, and then threshold. We are missing this image, so I need to make it either take a brighter image. So what's the threshold? First, we need to know that the value of each pixel goes from 0, which is the black one, to 255, that it's white. And in the middle there are different gradients. This one it's really dark, so it's closer to 0, and this one is closer to 255. Now we want to take all the pixels below a center number to 0 and all the pixels below another number to 255. So we'll have only actually the webcam is there, so we'll have only white and black. So we say that all the pixels with value below 245 will be black, all the pixels with value above will be white. Everything works correctly. Here we have all the shapes, black and white only, to work on. First thing that we need to know, how can we detect the shape? First, when we have the shapes, we can use the draw contour function. If you don't know what it is, you can check another video I made on the free tutorial series on YouTube about finding and draw contours, or it will be enough even the explanation here. So let's find these contours. Contours returns 3 values. We need only one, so underscore when we don't need the first one, contours the second one, and the third one we don't need it also, so underscore cv2.con I don't even remember, find contours, cv2.find contours. We want to find them on the threshold, the mode is cv2 dot ret tree. This is just the modality to find the contours, so let's not get into details about this. And then cv2 dot chain approx none. Okay, a quick explanation. What is this chain approx none? If, for example, in a contours we have a line with chain, there is no approximation in this case. The contours are just all the points around a specific area. In this case, we are going to give exactly every single point. If we say, for example, chain approx simple, if there is a line, there is no need to give all the points. You can just give one point and the second point and then connect the line. It will be the same result. So it will take less memory approximation. So actually, let's put chain approx simple. The result will be the same, but will take less memory. We have the contours and we can draw them on the original image. For CNT in contours, cv2.draw contours where on the image, so on EMG contours, it's CNT, and I'm missing something. I don't remember what's for this value 0. Okay, probably is this one to contour, to close it probably. Anyway, draw contours, and then the color, let's draw them black, so 0. And that should be enough. Let's see the result. Yeah, we are drawing them. You can see here. Let's give the size a bit bigger so we can add here the size of the contour. Let's say 5, and we can see all these black contours. We can see as the image is not perfect that here there can be some pixel that goes a bit out. For example, even in the triangle, this is not like a perfect line, some pixel goes out a little bit there. If we want to detect the shape, that can be a problem. The method we're going to use to detect the shape is to count all the vertices where the line convert. So in the square we know that we have 4, in the triangle we have 3, in the rectangle 4, in the pentagon 5. For the circle and the ellipsis will be a bit different. We will have to work on that. So if we have some imperfection, that can be a problem because we will get more vertices. With contours function, we have another function that gives us the chance to approximate the polygon to remove this small imperfection. So of course we give some value, and let's see how it works. So this draw contours. Let's now approximate the contours. So approx is equals to cv2.approx poly dp. We pass the curve, the contour CNT. Epsilon is the value of how much do we want to approximate. So let's write cv2.arc length of the contour CNT, and we want it to be close, true. And let's give a ratio. So we will see different ratio how they work. Let's give for example 0.05 per arc length, and then we want to be closed again. This one, the polygon must be closed. Or for example, if we had a pentagon, it will close only if you put false. It will take 1, 2, 3, 4, and this will leave it open, like without connecting it. Anyway, let's see what's the difference in the contours applying this this function. Let's put this one later here. So instead of drawing the original contours, we want to draw the approximate ones. So approx, and let's run that. We can see with the approximation that there are some difference. Here for sure we have 4 vertices. Here we have on the circle again 4, the triangle 3. The problem is that the ellipses and the circle get like a square. I mean, not the ellipses, but this could look like a square. So now we need to adjust the value of the arc length. So let's try maybe 0.02, so that we can get some difference of like counting how many vertices. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 7, 8. So this actually looks equal, like they have the same number, so it would not be good for us. Let's try 0.01, and now we have some difference. What can we do now? Now we can print the length of the sides. So let's see. Let's print the length of the approx. We have 4, 4, 4, 4, 13, 5. Why so many 4? These all 4s are small square that derive from some imperfection. So we can, for example, change a bit the threshold. Let's try 240. Okay, now it's better. Yeah, the threshold made already some big difference. So this one is a square, this for example the rectangle, this should be the ellipse, the pentagon with 5, the triangle with 3, another square, and the circle. So this way already we can reach a good, reliable result to detect the shapes. What if we did this instead of using the approximation, to use the original contour, CNT? Let's see. Oh, this way we'll get so big difference, completely not useful numbers at all. Okay, we got to the point where we can detect how many sides have the shape has. If we know this, we know a lot to go on. So if, for example, if the length of approx it's equals to 3, it means it's a triangle. Print it's 3, it's a triangle. doesn't make any sense to print this here. We want to see that on the screen. Exactly, we want to see the name just on the figure, not printed here, because it will not have any connection with the shape. So let's print approx. If the length of 3 is 3, let's print approx. If the length is 3, we are printing now this contour. So we are printing the first vertices, 966 and 39, which is this point. The second one, 1164 and 384, which is this one, and then last this one. The good thing when we have the points is that we can put some text. Just starting from the point, this point, we say put the text here, this is a triangle, using this point. So we need to extract the points with the function approx.ravel. So we print, because now we have 3 different points, array of array, so we don't want that. We could do this way, and you can see 1 and 2. We just need x and y. So it will be x, it's approx.ravel 0, so the first number, this one, and then y will be the number 1. Y, it's approx.ravel and then 1. Let's put now some text. Let's put the text this way. cv2.put text, where we want to put it on the image. The text triangle, then the position will be x and y. Font, just font, and then we will define the font. The scale, let's give size of 1, color completely black, so we can say 0. And that should be it. Now let's define some font out of the loop. Let's just define here the font. It's equals to cv2.font, and let's see what we find. Let's take just the first one, font Hershey complex. Let's run it right now and let's see what we get. It's triangle, exactly. So let's do everything for all the figures. If the length of approx is equals to 4, actually, okay, cv2.put text on the image. This is rectangle, x and y, font, and 1 and 0. We are basically putting everything like before, but just rectangle. There's a problem that here we don't have x and y. We could do the same as we did here, but it will make more sense to detect x and y before entering in the if condition. So this way, so we detect x and y, and then we can use it where we need it, not only if the length of approx is equal to 3. Rectangle. we can see here we could actually put it a bit above the image to make more sense, to see it better. We could put more above the image, but for the moment it's important for us to detect correctly. So we detect rectangle 1, this, and it's okay, and this rectangle 2. So let's complete this code. So if the length is 5, it's a pentagon. And if the length is, okay, pentagon detected correctly. If the length is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we can say for the ellipses, if the length is between 6 and 15, for example. So if there are different ellipses, could have less than that. We could take also them as well. If 5, no, let's say if 6 is less than the length of the approx, and the length of approx is smaller than 15, then that's an ellipse. Else it's a circle. So again, cv2 put text and circle. Let's run the code. We'll see circle, ellipse, pentagon, rectangle, triangle, rectangle. There is some improvement we could make. For example, for the square, of course, rectangle and the square, they have both 4 sides, 4 vertices, but there is different ratios. So like the square have the same width as the same height, and that's not for the rectangle. So we could, for example, compare width and height and see how, and then if they are equal, we can say it's a square, otherwise it's a rectangle. I'm not going to do that in this video. It's enough for you like to get at least a glimpse of how this works, and then you can expand it and improve it for your needs. This is all for this video.